Welcome back, everyone. This video is about building pipelines with result.map and result.bind. In case you haven't seen the last one, which is about the basics of pipelines with option.map and option.bind, please do so because that should serve as the ground for this one. This one is slightly more complicated than the previous one. Now, one of the limitations with the option container is that it either has data or not. There is no explanation for why there is no data. In other words, you cannot encode error or failure details in it, which is not a surprise because there is no data associated with the option container in the none state. It's a flat out none. While in the some case you can have some data. On the other side, the result has data in both the cases, in the success case or in the failure case, known as the OK and error case. So my goal in this example is to show you, in just like the last one, to show you how to build a pipeline with map and bind. So what I'm going to do is I'll use this record type as the base data type for all the examples or all the map and bind functions. Quickly recalling what we talked about, recap. Mapping is purely transformation. Binding is you may or may not transform, but it's a trajectory change point. It's a decision making point. It's a point where things may change direction. So let's first of all write some pure mapping functions. So assuming you have a student and it may have some name, age, roll number, we will write a function to let name to upper student, which is a student, equals to now. Okay, I'll do it this way. Student with name equals to student dot name dot. Righto. So you have a student as input, and you are using you are updating the record, copying, updating by just changing the name. Similarly, we will say add 5 to age, and in this case we are saying whatever the age is, make it 5, add 5 to it. So if you have a student, let student equals to name equals to name, age equals to 10, roll number equals to 1, 2, 3, 4, 5. So we have a student, and let's now start a pipeline. Okay, student, we pass this to result dot. I was supposed to say student, not student, name dot to upper, and add 5, and then whatever the result is, we will do percentage a, and before we start the pipeline, we will print the student and see what the effect of pipeline is. Okay. So initially we had name 10, 1, 2, 3, 4, 5. Now we have name in caps 15, which is 10 plus 5. And we haven't touched the roll number. It remains as is. So once again, very, very similar to the option pipeline, we have series of transformations. These are kind of useless functions. They're not doing a whole lot, but it's entirely up to you. Also, please remember or pay attention to the fact that it's not necessary that you have a student and you return out a student itself. It's a mapping function. It has t on the input side or t1 on the input side, and it may have t2 on the output side. As long as t1 t2 are both real data values, not container or derivative values, a mapping function may return anything. Just to give you an example, let student to name equals to student dot name. So this is a function which extracts the name out of student, and I can create a out of this pipeline. If I simply at this stage, if I inject this function, we should see that name got 2 upward, and then add 5 added to age, and then we are extracting the name out of it. So we started with OK student, meaning by a result of OK and OK of a result of student, on the other side error, same student at this stage. So this is the result of student slash question mark. The reason I am saying question mark right now is because we don't know the T error. We haven't invoked the T error side. So ignore that issue right now. That's how generics is handled in F Sharp. This stage is invoking this function. This function is returning another student. So the output of this stage is also a result of student or whatever. This stage is again returning a student. This stage is returning a string. So let's run it and see what happens. Can you see it now? So initially we had this, and now we have this. If I get rid of this stage, it will be student to student throughout. You started with a student, you ended with OK student, right? So because a lot of times when map examples are given, data types are not changed for simplicity's sake, so it shouldn't create any kind of confusion. That data type cannot be changed as long as there is a function which takes some input, produces some output. It doesn't matter. It in fact doesn't matter even for the bind. The output may be, if you're calling result.bind on type student, a result of student comma whatever, you may produce an output of whatever type. Now let's create a binding example. So I'll just change this stage itself, and I'll say that add age to 5, add 5 to age if less than 15. And what I'm saying is that if the student age is less than 15, add 5 to it. Otherwise, I mean, the name is not very descriptive. But what I intend to say is add 5 if age is less than 15. Otherwise, error, age is more than 15. And here what I'll do is I'll say if student the age is less than 15, then do this, else, and this should be returned as OK case. The other case is error case, and for the moment I'm keeping my errors as strings instead of full-blown exceptions. So if you look at the signature of this function now, it receives the student but produces a container of a result of student and string. while this on the other side receives the student and produces the student. And remember, you can't use this function here with map anymore. And since you have categorically used this function here, at this stage it becomes string, and here you need to use bind. So let's see what happens. All well, no problem. We started with name. The first transformation stage changed the name from whatever case to uppercase. The age is 10, which is less than 15. So we ended up with 15. 10 plus 5 is 15. Now let's just add the age and see what happens. And now this whole pipeline has failed. Okay. Just to make it slightly more comprehensive, I'll at this stage say name.map, and I'll use a lambda so that you can experience how to use lambdas also. So now it's a multi-stage pipeline. 2 upper for the name, validation plus transformation. Here is your validation resulting in an error, plus transformation, which is we are changing the age, and then a pure transformation that map it to this function. And this function is almost a copy paste of this function, except the fact that this is working on the roll number, this is working on the name. Let me make it 10 again so that you can see all these stages in action. Yeah, let me just change the roll number to so stage 1, stage 2, stage 3. And if you break this down, if you make it 18, this bind resulted in error state, and in the error state the next map is not going to perform anything. It will be a bypass. Just like if option you have none state, all the maps and binds are bypass function calls. Similarly with result, if the result gets into the error case, the error state, all the maps and binds are useless calls. The function is called, but the injected function is not passed. You keep on getting the input becomes the output, the input becomes the output effectively. Okay. So for this particular example, I showcased two things. One is similar things, a series of binds, which are typically, it's a very typical technique to use binds for validations. One downside with this approach of doing validations with bind, either with option or with result, is that you can at max capture one error in the entire pipeline, because the at whatever point there is a bind which changes the trajectory, which forces the failure, everything out after that bind is a bypass. So if we are producing error here, and imagine there is another bind here, so after this bind, that this map and the other bind are all useless, they are not getting called. So what you will end up with is the failure produced by this bind stage. So in the world of validation, there are two very clear or distinct ways of doing things. One is you have a lot of input, but you produce just one output, that is wherever the validation failed, you stopped and it terminated the sequence and you moved on. The other is you process all sorts of validations and present the output contains multiple errors, multiple validation messages or whatever, depending upon what your need is. So this particular approach, what we are talking about right now, cannot handle the case of multiple validation error failures and so on and so forth. That requires applicative functors. That's for future, not right now. Right now, my goal is to make you very comfortable with the ideology of map and bind. Like option, map is pure transformation, binders may or may not transform, but definitely can produce some kind of trajectory change. So on the blog, the two source files are linked, and two source files are here also. The program one is roughly what we talked about, all different sorts of examples, and building a complete end-to-end transformation pipeline, building a complete validation pipeline, and yeah. The other example, which is the comprehensive one, is slightly realistic, and I will step by step explain what is going on in this example, with the end result being something like this. This is a full blown, very realistic application example. Don't be bothered by the number of small functions that are written, because this is typically not part of your code. This goes into your central library, central area where you write the core part of application. If you remember chapter number 16, where I talked about how to stitch pure and impure world, how to isolate exception handling with such functions, and then how to create low level and high level wrappers. So a lot of what is happening in this source file is exactly this. These are your helpers for exception handling. Reading text from files as lines, and writing all the content as lines, and these are the helper functions. So you may actually ignore the implementation in this file, because that's not important for this particular session. Just there are two functions available: read all lines, which is give any file, and you will end up with result of the file content as string array or an exception. Remember, exn is exception. The other function is write all files. You give it a file and the lines, which is an array, and you will end up with result of unit, because writing is not producing any meaningful output, or an exception. So just remember these two. Rest everything is more for preparation of this example. Now, the rationale of this example, what is happening here, is mentioned here. In this example, read a text file, it has some name, which should have three lines of text. In the first line, you will have name, in the second line, you will have age, in the third line, you will have roll number, which maps to this structure, the record type, which is the name, age, roll number. After reading this file, perform validations. So there are validations mentioned in the above example. We will see it in the code later. Perform transformations, again as mentioned as illustrated in the code above, and then write this file back. This is the input file name, this is the output file name, and the new file that you are writing should have the same three lines of text, and print success of failure details. So first of all, I am explaining the IO functions that I have created. If you followed the previous video, one of the previous videos about isolating exceptions and how you can create wrappers, this shouldn't really bother you. So yeah, IO functions up to this point we already talked about. Validation functions I'll discuss later. These are transformation functions, again I'll discuss later. Now these are student record to string array conversion functions. When you read file content, you will be presented with a string array, which you need to convert it into a student instance, and then that is when you're reading. And when you're writing, you have a student, you have to translate it into a string array. So let's first of all discuss these two functions in isolation. First is lines to student, that is, you have read the file content and you have to transform that into a student record. And pay attention to the fact that there is no guarantee that based on what you have read, the student creation may or may not succeed. You may have read more than 3 lines, you may have read less than 3 lines. The first and the third lines are name and roll number, so doesn't matter, use whatever you have read. But the second line is an integer, which is age, and parsing that may fail. So this function returns student or exception captured in a result. So a huge hint you should already have right now is that somewhere in the pipeline this will be plugged in via a bind, not a map. So, and then you have a function which takes a student, you supply a student and it produces an array. It's a pretty straightforward code because of these pipes, the banana clips as they call it, fancy name. First part of the student is the name, first element, second is age to string, and the third is roll number. And so it's a pure transformation function. So this should again give you a hint that somewhere in the pipeline this should be injected via map. Now let's quickly just check the validation functions. This is a name validation function, that the name should not be null, or it's a standard boilerplate C# function which I'm using in F#. I'm saying age should should not be less than 10 and should not be more than 20. Basically should be between 10 and 20. And roll number, again copy paste of the student name validation. I'm not focusing on reusability of the code here, because with right structure of your functions, with right layout and with right partial application, you can reduce the repetitive nature of this, but ignore that. That's not important right now. Just pay attention. We are creating an exception over here and elevating it, lifting it, packing it into error. Student, okay. You received student, if validation succeeded, you lifted it into student. And all these functions, because they may or may not fail, once again, you will have to bind these. And these are transformation functions. There is a name, there is a student. You are producing with name to upper, age, you are adding +5, roll number, again, upper. These are pure transformation functions and should be used via map. So let's see what this pipeline, so this is a function which is not executing the pipeline, but it supplies the pipeline. All you have to do is give it the input file and the output file. And the very first function this pipeline invokes is read all lines. So what is read all lines? Read all lines, as I said earlier, give it a string, which is the input file name, and it will produce a string array or exception. So let's see what happens. So here we have read the file content, okay? And what we want to do next is perform series of validations. So the very first function, and this is not validation, I'm so sorry, this is lines or content to student, which is evident from the name itself. And these are 3 validations. And like I said earlier, all these functions may fail. Validation over here may fail, or conversion of the file content to a student instance may fail. So this result and a series of binds, because all of this may fail. And as I explained during the option example, every bind is producing some kind of nesting effect. here, and here. So the visual you should have in your mind should be clear what is actually going on. And after the validations are completed, we are invoking these three transformations. And the fourth transformation, again, I talked about converting a student into lines. Here it is. And then I am calling bind on write all lines. Write all lines may fail again. Write all lines is give me a file and the content and I'll write it. An important point to notice here is, and that's where things get F Sharp offers, or rather a lot of functional programming languages. The ability to use partial functions becomes exceptionally powerful. So write all lines has two parameters. It needs the file name and the lines. And so I am partially applying this, and the lines is coming out of the bind from the output of this student to lines is producing the result of string, array, or exception. So this bind will pass this over here. So this becomes one function which is expecting the another argument. So don't be confused by the partial application thing. I've already explained partial application earlier. If you haven't checked out the blog or the video, please do though, because a lot of after a point, once your fundamentals in F Sharp are clear, nearly almost everything will have some or the other direct or indirect connection with partial applications. And if you can't see what is happening, it seems like it's black magic. It's not. I am translating a 2-parameter function into a 1-parameter function because that 1-parameter function is already available in the pipeline if all went well. Okay, so quickly summarizing: input file, output file. With input file I start the pipeline and I end the pipeline with writing into the file, and depending upon what I have, your pipeline may fail here, wherever you see bind, and this in itself is an you're calling an uncertain function because you're reading file content. So this in itself is producing a result. So here to here and here is where your pipeline may have gone from success state or okay state to error state. And after everything is said and done, you have injected a lambda in the pipeline, which is saying if all goes well, you don't care about the output type, you're saying all done. If it failed, you are saying message. And this is what I have explained. And after everything is done, you can invoke this pipeline like this: pipeline, input file, output file, whatever the result is, like this. Once again, please run this to see what you observe. The key thing, just like the option example, is to observe where and how map and bind are used to stitch things together. With this example, I am hoping you can see the advantage of this approach, that you don't have to write yourself a spaghetti of try catch. If this happened, we need to do this. If this happened, we need to do this. No, you captured the basic operations into smaller functions. Though since this is not a full-blown real-life application, a lot of what is happening inside functions isn't too much, but that doesn't change the nature of what these functions are meant to do. If it was a realistic application, these functions would have more lines of code, but the highlight here is that stitching things should be a piece of cake, given you clearly understand what is map, what is bind, and since map and bind allow you to use only single argument functions, you must understand what is partial application. So if you understand these three concepts, you can write the most complex pieces of code which can be translated at the conceptual level, which can be translated into pipeline. You can translate it like this. You don't have to focus on the flow. You don't have to focus on ifs. You don't have to focus on if this happened, jump there, there's an error, clean up and do this. Bind and map pipeline internally takes care of everything. On that note, I'll conclude. Make sure to check out the blog where everything is more detailed, and check out the source code. All right, everyone. See you in the next one. Thank you.